Hello, today we're going to be working on the Hungarian algorithm. It's shown in chapter 11b of your textbook and is discussed on page 448 and 449. Now the Hungarian algorithm doesn't actually have a specific example associated with it, so I'm going to be using what they discuss on those two pages to talk you through how we apply the Hungarian algorithm. The first thing we should probably know is what's it used for. And essentially, it's for us to work out the most efficient relationship between two variables. So for example, I have 4 people and 4 machines, and each person has a different amount of time in which it takes to operate that machine. So what I would like to do is work out the most efficient relationship between person and machine. There's a variety of contexts that this can be used in. For example, it could be delivery drivers and different routes that they have to take. It could be teachers and subject areas. It could be ferries and their tariffs. So the Hungarian algorithm is all about working out the most efficient relationship. And we know from our previous discussions, efficient is essentially best time management or most cost effective. So what I have on here is the table that's shown on page 448, where it outlines the 4 people and the 4 machines. The values that are written in the table represents minutes. Now when we're working through the Hungarian algorithm, there's 3 key steps. The first is to look through the rows. The second is to look for columns. And the third, which this step sometimes isn't required, is for a crossover. But the example we look at today does look at the crossover as well. And what we want to do is identify 4 lines that cross through 4 different zeros. Now that might seem a little bit funny when I say it initially, but as we work through the problem I'll identify what I mean. So with this first step, what we want to do is have a look at the 4 rows. And within those 4 rows, I want to identify the smallest value. So for the first row it would be 30, for the second row it would be 30, for the third row it would be 30, and for the fourth row it would be 20. And what I need to do is subtract that value from each number in the row. So 30 minus 30, 40 minus 30, 50 minus 30, 60 minus 30. I'm going to do that the same for each row. So for example, this will turn to 0, this will turn to 10, this will turn to 20, this will turn to 30. I'd like you to take the time now to apply that method to the next 3 rows. I'm going to do that also. Okay, so before I mentioned something about identifying zeros and putting lines through those zeros. I'm going to use a different colour for this, and what I can see is I have a 0 here, 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 and here. Now with those zeros, if I was to draw a vertical line down, a vertical line down, and a vertical line down, I would only have 3 lines on my diagram. I need 4 lines on my diagram. Why 4? Because I have 4 machines and I have 4 people. So in order to get more zeros, I'm now going to look at the columns. So for the moment, just so it doesn't get too confusing, I'll remove the vertical lines that I've drawn. Okay, so now what I need to identify is the columns that didn't have a 0. And it was this column here for C. What I'm going to do is identify the smallest value within that column. And that smallest value is 10. Now what I'm going to do is subtract that smallest value from each number in the column. So this 20 will turn to 10. Pardon me. This 10 will turn to 0. This 30 will turn to 20. This 30 will turn to 20. Now let's have a look. Are there enough zeros that I'm going to have 4 straight lines on this table? Okay, so now using the straight lines, I want to try and cross out all the zeros. But remember, our first instinct would be to be cross line, cross line, cross line, cross line. That's not going to help us because there's going to be no values in which we can use. So we want to try and be efficient with what we're looking for. So when I look at this, I can cross here, here, and all the way across here. Now I have 3 lines. I'm looking for 4. So this is where things get a little bit tricky. To make it super clear, I'm going to cross through the ones that I'm talking about. Okay, what I need to identify is the smallest uncovered value. So that would be my number 10 here. It could also be this number 10 as well. And I need to identify a value that is being crossed over by 2 lines. That would be this value here, because it's crossed by our vertical and horizontal line, and this value here, vertical, horizontal line. What I need to do is add the smallest uncovered value. So that is 10 to this value. So this number 40 is going to change to 50. What I then need to do is subtract the smallest uncovered value from the remaining uncovered values. So that would be the 2 10s, the 3 20s, and the 60. I'm going to go through that now. If that confused you, stop the video, rewind the last 30 seconds, listen to that instruction again. I'm going to do what I just said and talk it through. Identify the smallest uncovered value, that is the number 10. And I'm going to add it to where the crossover value is. So these 2 40s are going to turn into 50. Then what I need to do is subtract this value from all the other uncovered values. So this will turn to 0. That will turn to 0. This will turn to 10. This will turn to 50. These 2 here will turn into 10. Now what do I want to identify is, can I use those 4 lines to cover those zeros? I have one that's crossing here, one that's crossing here, one that is crossing here, and now I also have a 4th line crossing here. So I now have the values that I need, which are these values here. Okay, this is the neater version of the mess we just had before. Now what I actually want to be focusing on is where these zeros are. So it might be worthwhile now redrawing this diagram so it looks a little bit more clear cut like mine does now. Now what the zeros indicate to us is a relationship, and an efficient relationship at that. So when I look at Wendy, she has a 0 in column A, column B, and column C. That means she has a relationship to A, B, and C. When I look for my next row, they have a 0 in B and C. So they have a relationship, I'll do it in a different colour, with B and C. When I have a look for my next row, Yolanda has a 0 for D. So she only has a relationship with D. And for Zelda, only has a relationship with A. Now what we've identified is the most efficient relationships in order to have the best operating time between these 4 workers and these 4 machines. The questions in 11B will build on this concept. Have an attempt at them, email me with your questions, as I'm more than happy to work through those as well. See you in period 3. Bye!